So looking at the oscilloscope, there are a whole lot of controls, but the important thing is to remember we're fundamentally looking at a graph of voltage versus time for whatever signal. And right now there are two channels on the oscilloscope. We're looking at channel 1. I can turn it off by toggling this button and back on. And I can change the vertical scaling here with the volts per division. So if you watch down here, it says channel 1, 1 volts. That's my scaling right now. That means each of these dotted lines is 1 volt. And then my time, I can change with the seconds per division knob. So if I turn it up, that's like zooming in time, and my time divisions are here. So 250 microseconds right now. Zooming back out, here is 1 millisecond per division. So just glancing at this waveform, we can tell a couple things already right away just from the scaling information on the screen. It's 1 volt per division, and if I look, the amplitude looks like it's about 1, 2, 2.5 divisions. So the amplitude is probably about 2.5 volts, something in that neighborhood. It's certainly more than 2 and less than 3. And if I look at the time, the period, one cycle starts right here, and it goes up, down, and back. And counting over, that's about 1, 2, 3 divisions, probably slightly more, but the period is probably about 3 milliseconds. So that's for quick measurements. If we want to actually measure more carefully, we can use cursors, and there's a button here to enable the cursors. Type is off right now, but I set it to voltage, and now what I have is 2 cursors that I can move up and down. And cursor 1, I'm going to put right at 0 volts. Cursor 2, I'm going to put up at the top of the waveform. So if I put that here, we can see the delta difference between those cursors is the amplitude of 2.48 volts. You can see that matches pretty well the 2.5 that I estimated from counting. And then we can also change, we can toggle with this button from voltage to time cursors, and so now we can measure a period. If we measure where the waveform crosses the 0 line, this is 0 voltage here because that's where the waveform is centered. So we cross here, and then the next crossing is right about there. The delta time difference between those two cursors is 3.12 milliseconds. And that corresponds, it tells us right here, that corresponds to a frequency of 320.5 hertz. So we've used the cursors to measure the voltage. I'll show you the RMS voltage in just a minute. We'll look at the meter as well, but the period we measured at 3.12 milliseconds, corresponding to a frequency of 320.5 hertz. But the oscilloscope very handily has automated measurements built in as well. We'll use these pretty frequently in the lab. So if I switch to measure, there's a whole host of automatic measurements set up here, and I pre-configured these for what we want today. But you can change what channel it's measuring on and the type of measurement. So right here, this first measurement is the peak-to-peak voltage, which is just twice the amplitude. And that gives us 5.08 or 5.12. You can see it's about twice that 2.48 voltage we measured for the V0 before. The RMS voltage, this is a calculation basically of the root mean square of the amplitude, and it can be useful when you're thinking about the power in a waveform, but it's basically always less than the amplitude here, and in this case it's 1.76 volts. We can compare that to a measurement with a voltmeter that I've got hooked up to the same signal. This is reading 1.726 volts. So this is the CRO VRMS is 1.76, and the meter V is 1.726. So that's those, and then we can see the period. Automatic measurement here is 3.11, just about milliseconds, and the frequency is 321 or so hertz. So this is automatic measurements on the oscilloscope. The other thing we can look at is over here on the function generator. I've set it to 321.4849 hertz. You can see it's bouncing around a little bit, but those are pretty small oscillations, fluctuations, a few decimal places over. So the F generator in hertz is 321.5. And that's a pretty close match to the 321.3 or so measured here. So that's measurement with the oscilloscope. Maybe what we'll do is one other measurement. With the function generator, I'm going to switch this so that instead of about 300 hertz, we're now at about 30,000. Maybe I'll turn it up even more just for some more contrast. Well, we'll do that. So I've set the F generator now to 31.8 kilohertz, so 31,000 cycles per second. And if we look back at the oscilloscope, you can see there's just a big black bar on the screen because we are not zoomed in enough on the time scaling to see it. So turning the seconds per division knob up till we get a few cycles on screen, now we can see our sine wave back. It's a lot faster, and our time scaling is now 10 microseconds per division. So maybe I'll give the amplitude a little spin just so we have a different value than we did before. And now the scaling here is the same. So the amplitude looks like it's about 1, 2, 3 volts, something like that. And the period is going to be 1, 2, 3 again, divisions, but this time the divisions are 10 microseconds each. So the period is going to be about 30 microseconds. But instead of going through the cursor stuff, we can just use the automatic measurements. We can see that CRO V0 is half of this value, so it would be 5.8 divided by 2. Or about 2.9. The CRO VRMS now is 1.99 volts. The meter V here is now 0.934. And if you remember, on that last measurement, we had pretty good agreement between the oscilloscope RMS and the meter RMS voltage. But that was at a much lower frequency. Now that we're at a high frequency, this thing is not responding as well, and so there's more of a discrepancy. The oscilloscope RMS is much more trustworthy at high frequency. So the meter V is 0.92 or 918, something like that. And then the period measurement is 31.5 microseconds, it looks like, corresponding to a frequency of 31.8 kilohertz. So that's kind of a quick overview of measurements on the oscilloscope, just so you know what to look for. It's always important to check the time scaling and the vertical scaling so you know what the units of the graph are. And usually it can be set up so that the automatic measurements are pretty useful, but you may occasionally see images presented with cursor measurements to measure features as well. So now you know what those are when you see them.